Welcome back, everyone. Yesterday we discussed how air masses and fronts affect the weather. Today we'll give examples of severe weather. The first example is thunderstorms. Thunderstorms are clouds that can be 20 kilometers high and bring in rain, thunder and lightning, and tornadoes. And we'll talk about those in a minute. Thunderstorms form in warm, moist, and low-pressure air, usually along a front, since the front forces the air to rise. This happens in a convection cell, meaning a cycle of air going up and down. At first, the rising air forms a cumulus, this tall cloud, and the air is called an updraft as it goes up. When condensation occurs and the water vapor turns to water, the drops become heavy enough to fall through the rising air. This creates a downdraft, or air that's falling down, that weakens the updraft and cuts off the moisture that's needed for the cloud to form, causing the cloud to evaporate and leave. Usually it's going to occur along the front, but sometimes thunderstorms will occur ahead of the front, and this is called a squall line. Strong winds come before a thunderstorm, since falling rain causes air to cool and sink and spread out ahead of the squall lines. A product of thunderstorms is lightning. Lightning is a discharge of energy from a thundercloud to the ground, to another cloud, or within the cloud itself. When larger and smaller particles collide within a cloud, the larger ones become negatively charged and the smaller ones become positively charged. The details of this are beyond the scope of this video. The larger, heavier particles fall to the bottom of the cloud, while smaller ones rise to the top. When separate positive and negative charges flow towards one another, they produce a spark, which creates a lightning bolt. The bolt heats the air and expands, creating a sound of thunder. Light travels faster than sound, so we see lightning before we hear the thunder. Lightning heats the air more than 25,000 degrees Celsius and will strike the highest protruding point available. Lightning is an electrical charge, so it will flow for some distance through material that conducts electricity like metal and water. Another product of thunderstorms are tornadoes. A tornado is a rotating column of air that touches the ground. Tornadoes form in the same convection cell as thunderstorms. However, these cells are larger, called supercells, and they rotate. The rotation begins with an updraft that's spinning, called a mesocyclone. It begins spinning because lower winds are blowing at a different direction and speed than the higher winds. These winds create a wall cloud, which is visible at the bottom of the storm cloud, and the tornado comes from the bottom of that. Now, not all mesocyclones create a tornado, and not all tornadoes have visible wall clouds. But tornadoes are going to appear as a funnel-shaped cloud of flying debris, and the air pressure at the center of the funnel is very low, which means it's going to be sucking air into it. Tornadoes travel at the back and with a thunderstorm. If a tornado is approaching, it might be hidden behind rain falling from the thunderstorm. Tornadoes can occur anywhere in the United States at any time of the year, but they usually occur in Tornado Alley, which is the area between Texas and North Dakota, and usually during spring or summer months because the warm air increases thunderstorms. Tornadoes can be classified based on the Fajita scale. It can be classified as weak, where it can damage chimneys, break trees, and blow over street signs; strong, where it can lift cars; and the most violent type, where it can rip sturdy houses from their foundations. Scientists have tried to predict tornadoes based on radar. A radar works by sending out a wave that returns as soon as it hits precipitation. So based on the time it takes for it to return, we can assume how far away the tornado is. Now, tornadoes will appear on a radar as a hook shape, but they don't always appear, making radar an inaccurate way to predict tornadoes. The National Weather Service, however, will issue warnings and watches to people to give them time to find shelter before a severe thunderstorm or tornado. In case of a tornado, stay indoors, try to get into a basement or cellar or the ground floor, and avoid windows. Another type of severe weather is a hurricane. A hurricane is a large rotating storm that comes from warm tropical places. A minimum speed of 74 miles per hour is needed in order to be considered a hurricane. It needs warm, moist air for a long time in order to form. Now remember, when water vapor turns to water and gets cooler, this is called condensation, and the heat that the water is holding onto, it lets go and puts into the air around it. And in this case, large amounts of heat are going to fuel a hurricane. Air pressure at the center of a hurricane is very low, and it gets its energy from the heat of the ocean. Because hurricanes need warm water, hurricane season is usually in the warmer months between June and November. Hurricanes have a spiral shape. On the outside is mild rain, and the intensity of the rain increases as you get towards the center of the hurricane, known as the eye. In order to develop into a hurricane, it needs to rotate. And this is caused by the Coriolis effect, which is that the winds are never going to go straight, they're always going to turn, which we discussed when we talked about wind patterns. Hurricanes will weaken rapidly once it reaches land, but it still can cause tremendous amounts of damage along the coast and on the land. A storm surge is when strong winds blow water in a dome shape, raising the sea levels higher than normal. Meteorologists rate a hurricane's strength using the Saffir-Simpson scale, which helps us predict the damage that will occur based on the wind speed that the hurricane currently is. The last type of severe weather we'll talk about are blizzards. A blizzard is a storm that occurs in winter with cold enough temperature to create snowfall. However, to be considered a blizzard, you need the following conditions. The winds need to be going at least 35 miles per hour, the temperature needs to be under 90 degrees Fahrenheit, and the snow needs to reduce visibility. This wraps up severe weather. When we return from the break, we will discuss weather forecasting and the climate. Make sure to answer the questions in the form below. Thank you so much for joining us on Google Classroom, and I'll see you all after the break. Have a happy, healthy, and safe holiday.